Hello, everyone. In this session, we would be discussing about Radix notation. Why Radix notation is important and where we would be using that. So, we would be discussing about what is the formula of that Radix notation, how to generate the hash index. We will definitely see some examples and a complete picture overview, like how everything works behind. And we'll also see what are the time complexity analysis. We have some operations which we are doing. So we will be seeing about time complexity analysis, and finally, what are the limitations of Radix notation. So these are the topics which we would be covering in this session. So moving forward, we will see like what is Radix notation. Before discussing about Radix notation, let's understand why we are using this. Now, if you have already seen my hash tables and hashing videos, we have covered very clearly, like we use something called as a hash table, and we had something called as an integer value. And this integer value, we passed it to a hash function. And then on, depending upon what is, we have seen very clearly, like what does hash function do and what are the things, everything it does. So hash function finally gave us some hash index, and we took that index and we went to that particular index of the hash table. So this is what we have done. So basically we have done hashing with integers. Now in our course curriculum, like currently in bioinformatics or large scale data structures, so what we do is we deal with characters, we deal with strings. So everything is human genome. So now in those cases, so basically to be precise, how to generate a hash value or a hash index for a string. Here comes the question. We have done hashing for integers. Now how to do hashing for strings? There are so many methods how you do, how you hash strings and generate hash indices. One such method, what we would be following is something called as Radix notation. So that's why we are using Radix notation here. So we'll see. So this would be our agenda. We have something called as a string, and this is what we have to generate. Assume the hash index of the string is 147. This is just assumption. Now how to convert this? This is the thing our agenda would be. So this is a formula. I know this formula is not straightforward. Examples make it much clear. I'll make it much easy with examples. So this is the basic formula. So you have something called as an alphabet. R indicates the alphabet or the base index as well. We'll see what is that. And this is a formula which we would be doing. Your I starts from N. N means the last character of the string. If you have a string, I starts from the last character and it goes on till 0th index. So this is what it is. I is ranging from N till 0. And we are doing some operations Pi and R power N minus I. So here R is base. Pi is what? Pi is ith character of that particular string or text in base notation. So I know this is not clear, but just remember that this is the formula which we would be following. Examples will make it much clear. Now, when we are working in bioinformatics, specifically human genome, so we would be dealing only with few characters, which would include A, C, G, T, N. There would be some other characters also like K, if you don't know anything, but that is fine. Majorly, you would be dealing with only this 5 characters, A, C, G, T, N. So obviously, now we'll try to represent these characters in form of integers so that the hashing would be easy. The conversion to Radix notation would be easy. So in the examples, whatever we would be covering, we will consider A as 0, C as 1, G as 2, T as 3, and N as 4. So this is the representation of characters. We'll see example and the formula. I don't want to explain examples in this formula way. I'll tell you the easy way how to do it, but that internally follows the formula. So that is using the formula, but I'll tell you the easy way how this everything conversion is happening. Now, assume the string is ACA and I want to convert it to some radix value. This is my aim. And what is R? I already said you, R is nothing but the alphabet and it represents the base. Now, what does that mean? Alphabet is nothing but the set of characters, right? Even in English, in English, when we take strings, that will obviously comprise from alphabets A to Z. Nothing would be other than that, right? So here, this is the alphabet set. And how many number of characters we have here? 4. So your base is 4. This is what is important. So the base is 4 here because we have only considered 4 characters. Here we didn't consider n. This is one such example. We have other examples which considers n. So here the base is 4. Now I'm taking the string ACA and I want to generate a radix value. Now here in the formula, it is very clear. What we said, start from the nth character, that is the last character, and come till 0. So what does that mean? You start your considering characters from the last character till the first character. So that's the reason this arrow indicates that you start from this A and go till this A. Correct? Now, what you do is, now we know from where we have to start. Pick this first character A. Fine, I know that this is the character A. So when you pick A, pick what is the base value of it. What is the base value of A? It's 0. So take that 0. This is what PI means. PI is ith character of the text in base notation. Fine. Into, what is the base value here? 4. What does 4 signify? You have 4 characters, correct? 4 power 0. This is what you remember. I mean, remember that your power starts from 0 and it keeps on increasing. So this will make much clear here, because I don't want to explain how it is converting from r power n minus I, because here we know what is pi. Here r power n minus I values, I don't want to confuse you. So I'll tell you how significantly it happens. So now I picked A and the base is 4. It is 4 power 0. Next, it becomes 4 power 1. It becomes 4 power 2. That is what it happens. So now next, what is the other character? It's C. What is the base value of C? It's 1. 1 into, now you take 4 power 1. This is how it happens. This is a simple logic. Plus, now pick the next character A. What is the base value of A? 0. 0 into, now what would be the power? 4 power 2. This is how it works. So just remember like that. Now, basically what r power n minus I means is, here we were at the last index, correct? So n means the number of characters. We have 3 characters here. The string length is 3. And what is my I initially? I is n only, right? Because I is starting from the end. I is 3. So initially what would be r power n minus I? R is 4, because that is base. 4 power 3 minus 3 is what? 0. So that's the reason here it is 4 power 0. Next, when I come to this character, what is my I now? I is 2, right? Because I got decremented. So now what is 4 power n minus I? It is 4 power 3 minus 2, which is nothing but 4 power 1. That's why here it is 4 power 1. So this is how the base with the exponent keeps on increasing. So don't, I mean, even though if you don't understand this formula, just remember that the base keeps on increasing. If it is 4, the first one will have 4 power 0, 4 power 1, 4 power 2, it keeps on increasing. So now what is the result here? 0 into anything is 0, plus 1 into 4 power 1 is 4, 0 into something is 0. So this is 4. Now the radix value is 4. We will see at last why we are calculating this radix value, but understand this radix value 4 is the representation of this string AC. Now we converted string to radix value. Fine. We'll see one more example. Now what is AAC? Pick the first character, C, correct? What is the base value of C? It is 1. 1 into 4 power 0. Why? Because again here the base is 4 only. You have only 4 characters. 1 into 4 power 0 plus, pick this character now, A. What is A? 0. 0 into 4 power 1 plus, now pick the other A. What is A here? 0 in base notation into 4 square. Correct? So 1 into 4 power 0 is 1. This is 0 and this is 0. Now this is 1. So here we got radix value as 1. What does this signify? Radix value 1 denotes that it is the representation of the string AAC, whatever is there. Now let's take the example of some other alphabet, which you would be also finding in homework assignments. Now we are considering 5 characters. So this is my alphabet set. Now my alphabet has, this one set of characters, A, C, G, T, N. Now what is my base? Here base is 5 because I have 5 characters. Clear? And now I want to convert this string into radix value. It is the same thing. Oh, sorry. Yeah, it is the same thing. What we have to do? First, pick the character from the last. It is T. What is the base value of T? It is 3, right? So 3 into, now it's not 4 power, it is 5 power because base is now 5. 5 power 0 plus, now what is the next character G? What is the base of G? 2. 2 into 5 power 1 plus, what is the next character N? What is the base value of N here? 4. 4 into 5 square plus, the last character now is A, correct? So what is the base value of A? 0. 0 into 5 power 3, correct? Now 3 into 5 power 0 is 3. Yeah. Plus 5 into 2 is 10. Plus 5 square is 25. 25 into 4 is 100. This is 0. Now this gave me 113. Yeah, I guess the calculation is correct, but don't focus on calculation, how the formula is working. This is what you have to consider. This is how the formula works. You take the base index notation and you keep on increasing the base with the power. R power n minus I. Yeah, so this is 113. Now what does 113 signify? 113 says that, okay, this is the representation of this particular string A and GT. This is how you do. Now we will just look at the overview. Till now, when we discussed in hashing, we discussed so many techniques like chaining as well as probing. In probing also, we discussed about linear probing and quadratic probing. So what we have done there is, when we had an integer, we always pass that to the hash function. Assume the hash function here gave an hash index 3. Then we directly went to hash index 3 and placed the element. If it is separate chaining, I mean, if it is chaining, we maintained a linked list. If it is probing, we just used linear probing or quadratic probing. But what my intention here is, we passed an integer to a hash function and that hash function has generated a index. This is for integers, which we have done. Okay. Now, what we are trying to do is, we have something called as a string. This is the process which we would be doing, even in the homework assignment as well. We have something called as a string. We first created a radix. We made a radix conversion and we got some radix value. Assume the radix value for this string here is 174. This is not correct. I just took some random value. But assume for this string, the radix value is 174. Fine. Now, why we generated the radix value? Why we are trying to do this? Because our intention is to consider these strings and put into hash tables, right? This is what we are trying to do. That's the reason. Once you get the radix value, now pass this radix value to the hash function. This is how internally it works. And now finally your hash function will generate something called as a hash index. Assume in this case, if it is 5, now you go to the fifth index in the hash table. So if you compare integers, hashing in integers and hashing in strings, this step is common. Hash function and the hash table. This is common. Now what is changing here? The input to the hash function only is changing. In this case, we directly passed integers, but here we are dealing with strings, converting it to radix conversion. I mean the radix value, and then we are passing it to the hash function. This is how hashing will be done in strings. So this is what we would be doing in our homework assignments as well when we deal with hash tables. Now we will see what is the time complexity. In hashing, we have discussed that our ultimate agenda to deal with hashing is to generate a worst time complexity of 1. This was with integers. If we had some good hashing functions, and we also have seen clearly like what are the best ways to make your hash functions more efficient in integers. So watch that video once again. So hashing in integers was big O of 1. Now the question comes, what would be the time complexity for hashing strings? Now we have to be very careful in understanding the time complexity here. What exactly we are trying to do? Now assume if I took some string A, N, C, G, A. What did we do? To hash this, we went to the last character, we used some formula. So from there again, we were picking each and every character, correct? If you look into the formula was something like I is equal to n to 0. So from the last character, go to the first character. And for each and every character, we were doing some formula, something like some 2 into 4 power 0 plus 1 into 4 power 1. These calculations we were doing, right? So we kept on calculating for each and every character, and finally we got a radix value. This is which we have done. Now, what is the time complexity here? Because we found out the radix value by picking each and every character. Now assume the length of your string is n. Assume n is your length of the string. You traverse the entire string, entire length of the string. So the time complexity here for hashing strings is big of n, where n is your length of the string. It varies. If your length of string is 1, it is big of 1. If your length of string is some 2 billion, then it is like something like that. So it depends upon how many number of characters. Because if you want to hash the strings, obviously you have to iterate the string, right? Because when you iterate the string, only then you will be getting the radix value. So this is a very important thing which you have to remember. So hashing integers and hashing strings are completely different. Both the time complexities are not same. Yeah. Now, what are the limitations of using this radix method? Because yeah, it is definitely not suggested when your base is high. Now, what does that mean? Now, when we are working with bioinformatics or this human genome, what was our alphabet set? Maximum, it was only 5 characters, correct? Now, when I say when base is high, what does base mean? Base is the number of characters, right? Base is 5 here. Now, when base is high means what? When you have more number of characters. When can you assume that you have more number of characters in this case? Correct. When you take an English alphabet, yes or no? When you take English alphabet, how many alphabets we have? 26. It starts from A, B, C till Z. So what is the base here? The base is 26 here, correct, right? Now, if you want to use the same radix notation for the English alphabet, what would it be? Suppose, for example, I want to generate, assume here A is 0, B is 1, C is 2, and Z is 25. Assume this is the case. And I want to generate a radix value for something like A, B, F, or A, B, C, D, something like this. Assume if it is A, B, C, Z maybe, instead of D, I'll say A, B, C, Z. Okay. Now, how to find the radix value? Pick the base of Z. What is the base of Z? It is 25. 25 into what is the, this is the value. This is the base notation value. Now, what is the base here? It is 25 power 0. And then pick the character C. What is the base notation of C? 2. 2 into 25 power 1. Now pick B. What is B? 1. 1 into 25 power 2. Plus here it is A. What is A? 0. 0 into 25 power 3. So now I guess you would be understanding the disadvantage. In human genome, the base was very small. It was only 4 characters or 5 characters. So 4 power 20 is also like, okay, it's fine. But now just think what this 4 power 20 becomes 25 power 20 if you're dealing with English alphabet. Now this is very huge, correct? When you try to solve this, this will actually exceed your integer value. This will also exceed. We have data types. The maximum, what we have integer, we have long int, we have unsigned integer also, correct? So there might be some cases where all these data types also cannot handle your result because this value is too huge. So that's the reason it is not suggested when your base is high. Now the question comes, is this a limitation when we are dealing with human genome? No, because at max our alphabet will be only like 4 or 5 characters, and that is fine. So that's the reason we are using radix notation, because that is simple and easy to use, and it is also okay for our use case because our alphabet size is small. So this is how you convert your strings to radix value, and from that radix value you generate a hash index and place this particular string to that hash table. This is how you have to solve for your homework assignment as well. Thank you so much. I hope it was clear.